Hi, I'm Patty Works. I'm going to lead you through this unit orientation video for the 5th grade unit, Modeling Matter. In Modeling Matter, students take on the role of food scientists working for Good Food Production Incorporated, where they are introduced to the ideas that all matter is made up of particles too small to see, and that each different substance is made of particles or molecules that are unique. Students are challenged to solve two problems. One problem requires them to separate a mixture and remove a harmful red food dye. The other problem requires them to make unmixable substances mix in a salad dressing. Students are challenged to use the particulate model of matter to explain their work to the president of the company. In doing so, students figure out that the properties of materials are related to the properties of the nanoparticles that make up those materials. As they work through the 3 chapters in this unit, they gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they construct the understanding that observable properties of matter result from molecular properties. They learn that mixing is a result of attraction between molecules of different substances, and that separation is a result of the attraction between molecules of the same substance. This unit is a modeling unit. In their role of food scientists, students develop skills with the science and engineering practice, developing and using models. Students first create models of molecules at the nanoscale to explain what they observed on an observable scale, and then use physical models to show how properties of molecules affect interactions between and among different kinds of molecules. They use, develop, and revise models throughout the unit. The focal cross-cutting concept in this unit is scale, proportion, and quantity. In their role as food scientists, students delve deeply into the particulate nature of matter as they investigate what's happening at the macro scale and nanoscale in 2 food-related mixtures. As students begin to understand the nanoscale explanation for the observable separation of dyes, they create and revise a series of nanovision models of chromatography, dissolving, liquids that mix and don't mix, and emulsifiers to describe their thinking. Students return to the idea of scale again and again throughout the unit through a variety of modalities. Every Amplify Science elementary unit also includes a focal sense-making strategy, which students leverage as they read and also during investigations. This unit's sense-making strategy is making inferences. Like most units in Amplify Science K-5, the main writing genre is explanation. Well, that's the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight 1 or 2 key evidence sources students use. But remember, in every chapter, and indeed every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students investigate and learn that all matter is made up of particles too small to see, atoms connected together to form molecules. If 2 pure substances have different observable properties in the same conditions, they're made of different molecules. Key evidence sources include information gained from investigations. Students observe and record properties of mixtures and use chromatography to separate a food coloring mixture. They apply observations of models and discuss it in terms of what they observed in chromatography. At the end of Chapter 1, students return and apply these ideas to the anchor phenomenon. They explain that the different dyes that were mixed together have different properties, like different colors. So they infer that they are made of different molecules. The molecules in the mixture that are carried up the paper by the water are attracted to the water and mix with it. As the water travels up the paper, different kinds of molecules travel different distances because their molecules are different sizes or because they have different attractions to the paper. In Chapter 2, students learn about mixing. They find that molecules of one substance can be attracted to the molecules of another substance. Different pairings of molecules have stronger or weaker attractions to one another. When the molecules of one substance are strongly attracted to the molecules of a second substance, the molecules mix together and one substance dissolves into or mixes with the other. In this chapter, students read and discuss the book Solving Dissolving and make digital nanovision models of a soluble substance and an insoluble substance. At the end of Chapter 2, students are able to explain more about the second problem as they try to figure out why salad dressings may or may not separate. They find that salad dressings with sediments contain solids that are not soluble, and salad dressings without sediments contain soluble solids. The molecules of water and the molecules of different solids are different from one another. When a solid dissolves in water, if it is soluble, it means that the molecules of the solid are attracted to the water molecules. When a solid does not dissolve in water, it means that the molecules of the solid are not attracted to the water molecules. In Chapter 3, students investigate and find out more about substances separating and forming layers. The molecules of a substance can be more strongly or less strongly attracted to other molecules of their own kind. If the molecules of a substance are more strongly attracted to their own kind of molecule than to the molecules of another substance, the two substances will separate. However, when a third substance with molecules that are strongly attracted to the molecules of both of the separated substances is added, all three substances can mix. In Chapter 3, students revisit key models used throughout the unit and revise their ideas as they write about what happens to the molecules of two liquids when you mix them. They make and evaluate digital nanovision models of emulsification. At the end of Chapter 3, students are able to explain that when liquids do not mix together, they form layers. Liquid ingredients in a salad dressing separate after being mixed if the attraction between molecules of one liquid is greater than the attraction between molecules of different liquids. However, if an emulsifier is added, the liquids can mix because the molecules of the emulsifier are strongly attracted to both the A and B molecules. I hope you're feeling excited to start teaching this unit. In addition to the resources on the Amplify platform, check out the at-home videos and the at-home unit to help you teach the unit remotely. You can use any combination of these resources to engage your students in figuring out about modeling matter. Please let me know how I can help you plan for instruction. I'm Patty Works, and my email address is pworks@amplify.com. Thank you very much.